Have you ever gazed up at the night sky and found yourself pondering about the origins of the universe? Let's take a moment to journey back in time, far beyond the reach of human history, to the very birth of the universe. A time when there were no stars, no galaxies, no planets. There was nothing but a point, infinitely small, infinitely hot, and infinitely dense. This point, this singularity, is the starting ground of our cosmic tale. This is the heart of the Big Bang Theory, the most widely accepted explanation for the origins of our universe. About 13.8 billion years ago, our universe was this singularity, a point so tiny that it defies our comprehension. And then, in an event of unimaginable scale and power, it began to expand. Picture it as the ultimate explosion, a big bang if you will. But this was not an explosion in the traditional sense. It was space itself that was expanding, and it did so at a rate faster than the speed of light. As it expanded, the universe cooled and matter and energy began to form. The Big Bang Theory is not just about the birth of the universe though. It also explains the creation of all the matter and energy we see today. Everything that exists, from the smallest particle to the most distant galaxy, emerged from this moment of creation. This is not a simple concept to grasp, and that's okay. The birth of the universe is a complex and captivating subject filled with mystery and wonder. It's a testament to the power of scientific inquiry that we've been able to learn so much about an event that took place billions of years before our own existence. Imagine everything you see, everything you touch, and everything you know started from a point smaller than a single atom. Would you believe if I told you that we have a baby picture of the universe? Now what if I told you that this picture was not a conventional photograph, but one made of light, the oldest light in the universe to be exact? Here's the story. In the early 60s, scientists stumbled upon a peculiar kind of radiation. It was faint, it was everywhere, and it was unlike anything they had ever seen. They called it the cosmic microwave background, or CMB for short. The CMB is the afterglow of the Big Bang, a whisper of light that has been traveling through space for almost 14 billion years. But what makes the CMB so special? Why is it considered a baby picture of the universe? Well, the universe, like us, has had its phases of growth. The CMB is a snapshot of a time when the universe was just 380,000 years old, a cosmic baby if you will. At this stage, the universe had cooled down enough for atoms to form, allowing light to travel freely for the first time. This light, the CMB, is a relic of that time, a fossil of light. What's even more fascinating is that this discovery provided strong evidence for the Big Bang Theory. The CMB was exactly what the Big Bang Theory had predicted. A uniform omnipresent radiation that was a remnant of the universe's hot, dense beginnings. It was a game changer, a cosmic clue that helped solidify our understanding of how the universe came to be. But the CMB is not just a window to the past, it's also a tool for the future. By studying the tiny variations in the CMB, scientists can learn about the universe's early structure and its evolution, helping them predict what the future might hold. So the next time you look up at the night sky, remember that you're not just seeing stars and galaxies. You're seeing a cosmic narrative, a story told through light, a story that begins with the baby picture of the universe. The cosmic microwave background is a snapshot of the universe when it was just 380,000 years old, a cosmic baby picture. Ever wonder how the universe went from a hot, dense state to a cosmos filled with galaxies, stars, and planets? Let's take a cosmic journey back in time, when the universe was a mere infant. Following the Big Bang, the universe was a hot, dense soup of particles and radiation. Over time, as the universe expanded and cooled, matter began to coalesce under the influence of gravity, forming the first structures in the universe. These structures were vast clouds of hydrogen and helium gas, the simplest and most abundant elements in the universe. As these clouds continued to collapse under their own gravity, they formed dense cores. It was in these dense cores that the first stars ignited, about a few 100 million years after the Big Bang. These stars, composed mostly of hydrogen and helium, were much larger and hotter than the stars we see today. When these first stars exhausted their nuclear fuel, they exploded in brilliant supernovae, scattering heavier elements into space. These elements, forged in the heart of stars, would become the building blocks of future stars, and eventually, planets. While stars were forming and dying, gravity was also shaping the large-scale structure of the universe. Over billions of years, matter in the universe clumped together under the influence of gravity, forming galaxies. These galaxies, vast collections of stars, gas, and dust, are the cornerstones of the universe's large-scale structure. Our own galaxy, the Milky Way, is one such galaxy. It's a sprawling, spiral galaxy, home to hundreds of billions of stars, including our Sun. Our galaxy, like all galaxies, is a cosmic recycling center, where gas and dust from dead stars are recycled into new stars, planets, and possibly life. So the next time you gaze up at the night sky, remember, every star you see is a testament to the universe's long and storied history of star formation, and every galaxy is a snapshot of the universe's grand cosmic evolution. From the ashes of the first stars, galaxies like our Milky Way were born. Did you know that the universe is still expanding, and at an accelerated rate? This isn't just a fanciful idea from a science fiction novel, but a reality that cosmologists have been grappling with for decades. The universe, it seems, is not content to simply exist. It's growing, stretching, and evolving in ways that continue to baffle and astound us. In the early 20th century, scientists like Edwin Hubble discovered that faraway galaxies were moving away from us. The further they were, the faster they seemed to be retreating. This was a clear indication that the universe was expanding, a concept that fundamentally reshaped our understanding of the cosmos. But the plot thickened in the late 90s when researchers found that not only was the universe expanding, it was doing so at an accelerated pace. This was a shocking revelation. After all, one would expect the gravitational pull of all the matter in the universe to slow this expansion down. So what could be causing this acceleration? Enter dark energy. This mysterious force, making up about 70% of the energy content of the universe, appears to be the culprit behind this accelerated expansion. But despite its pivotal role, dark energy remains one of the greatest enigmas in modern science. We know it's there, we can measure its effects, but we can't see it, and we don't yet fully understand it. As for the future of the universe, it's still up in the air. Some theories suggest a big rip, where the accelerated expansion eventually tears everything apart, from galaxies and stars right down to atoms. Others propose a big freeze, where the universe expands to the point that stars burn out and all becomes dark and cold. These are unsettling prospects, no doubt, but they are part of the ever-evolving narrative of our universe. A narrative that we, as sentient beings, have the privilege of participating in and attempting to understand. We may not know what the future holds, but we do know this. The universe continues to write its own story, and we're a part of that grand narrative. So where do we fit into this vast universe? To answer this, let's first consider our home, the Milky Way galaxy, a swirling mass of around 200 billion stars. Yet it's just one among hundreds of billions of galaxies in the observable universe. Amidst this staggering enormity, our solar system with our sun and its orbiting planets is but a tiny speck. And on one of these planets, third from the sun, lies Earth, our home. It's hard to fathom, isn't it? Our entire history, all our triumphs and tragedies, have played out on this tiny stage in a vast cosmic arena. Now let's shift our perspective and think about time. Scientists often speak of cosmic time. Imagine the entire history of the universe, around 13.8 billion years, compressed into a single year. On this scale, the Milky Way forms in May, our sun and Earth in September. Life begins to flourish in late November. And humans? We show up in the last hour of December 31st, just moments before the stroke of midnight. Our recorded history, everything we know and have achieved, fits into the final seconds. It's humbling, isn't it? We are latecomers in the cosmic story, yet it's this very story that has allowed us to exist. The elements that make up our bodies were forged in the hearts of stars, dispersed in supernovas, and eventually came together to form our planet and eventually, us. So, where do we fit into this vast universe? We are the universe's way of understanding itself. We are the result of billions of years of cosmic evolution, a testament to the incredible journey from the Big Bang to the present day. As we look up at the stars, let's remember our cosmic roots. We are not separate from the universe, we are a part of it. We are made of star stuff, the children of stars. Remember, we are but a small part of a much larger cosmic symphony, a testament to the universe's incredible journey from the Big Bang to the present day.